we're going to look at more properties of trig functions. So first thing I'm going to do is draw a beautiful unit circle. I should be using a straight edge, but I'm not. Okay, we have 1, 0, 1, negative 1, 0, 0, negative 1, and you certainly do not have to draw this every time. I think it's helpful. And let's keep in mind that x is cosine and y is sine. And let's keep in mind that tangent is sine over cosine. Okay, so we know that secant is 1 over cosine. We know that cosecant is 1 over sine. And cotangent is cosine over sine. So one thing I had mentioned to you before was that in quadrant 1, everything is positive. In quadrant 2, cosine is negative, sine is positive. In quadrant 3, both values are negative. And in quadrant 4, cosine is positive and sine is negative. And of course, you can figure out then if the cosine is positive, the secant is positive. If the sine is positive, the cosecant is positive. If either one of the sine or the cosine is negative, then tangent is negative. And if both of them are negative, then the tangent is positive. So if you're asked to evaluate something like, say, find the value of the 6 trigonometric functions, I'm going to abbreviate. Find the value of the 6 trigonometric functions given, how about the cosine of theta is, let's say, negative 1/3, and the cosecant of theta is less than 0. The key thing here is knowing which quadrant does this angle lie in. I don't care what the value of theta is. I just care which angle, or sorry, which quadrant it lies in. Okay, cosine is x, so I want x to be negative. And my cosecant, which is the reciprocal of the sine, and the sine is y, I want y to also be negative. If you get the quadrant wrong, you're going to get all of your signs wrong, your positives and negatives. So better make sure you're really super careful about that. So this angle is in quadrant 3. Quadrant 3. If you're asked to show work, like you need to show work, where is it, etc. Okay, so it's some angle. Don't know what it is, don't care what it is, but it's some angle theta in quadrant 3. Okay, so the cosine is negative 1/3. So cosine, that's opposite. Cosine's adjacent, sorry. Adjacent over hypotenuse. Fix that in a second. And I need to find the opposite side. So I'm going to use Pythagorean theorem. So it's going to be negative 1 squared plus, in this case, y squared. It doesn't matter what variable you use, is 3 squared. So I believe that is root 10. 9 minus, so this is negative root 10. And now you can answer the question, but you're going to lose a lot of points if you've got the negatives wrong. If you lose a point or half a point for every negative, that can seriously add up. Okay, so the sign is negative root 10 over 3. Cosine was given to you. The tangent is root 10. The cosecant, I did not leave myself enough room. The cosecant is negative 3 root 10 over 10. Negative 3 root 10 over 10. The secant, you should at least be able to get the secant right because it's just the reciprocal of negative 1/3. So the secant, I did not leave myself enough room. Secant is negative 3. And the cotangent is, root 10 over 10. So it's just a matter of analyzing, understanding that third quadrant is where the triangle lies. Let's talk about even and odd properties. So about even and odd properties. So if you recall even and odd properties from chapter, I don't know, 2, 3 maybe, the f of x is equal to the f of negative x. This is even y-axis symmetry. Think about the parabola. If you're like, oh my God, I just can't keep it straight, always go back to the parabola. What do I mean by that? If the f of x is x squared, the f of negative x is negative x squared, which is x squared. So the f of x is x squared, the f of negative x is x squared. That's a parabola. Parabola has y-axis symmetry naturally, and it's even. Okay, if the f of negative x is the opposite of the f of x, this is odd, and it has origin symmetry, and there's no test for x-axis symmetry. There might be, and you can discover it, and then you can be famous in the math world. This applies to trig functions. This applies to trig functions. If you have, let's just stick with the sine of 30 degrees. Sine of 30 degrees is 1/2. Okay. What about the sine of negative 30 degrees? What about the sine of negative 30 degrees? So the sine of negative 30 degrees is negative 1/2. You just need to start knowing those things pretty darn quick. I plugged in the opposite of theta, and I got the opposite value for the sine. So the sine of theta is the opposite of the sine of negative theta. I plugged in theta, negative theta. I plugged in 30, negative 30, and I got the opposite value. My apologies, I shouldn't have the extra negative sign there. Let's try that again. I think I have white out. Sorry. When I plugged in, you know what? I'm just going to rewrite it down here. The sine of negative theta is the opposite of the sine of positive theta. Sorry about that. 30 degrees, negative 30 degrees, you get the opposite. If theta is 30 degrees, The sine of negative 30 is the opposite of the sine of positive 30. The sine of negative 30 is the opposite of the sine of positive 30. So let's do another one because I know I messed that up. Let's do another one. The sine of 225 degrees. So 225 degrees is in the third quadrant. So this is going to be negative root 2 over 2. The sine of negative 225. If you need to draw that, let's draw it out to the side here. Negative 225 ends up in the third quadrant. 45-degree reference, that becomes positive root 2 over 2. So the sine of the negative angle is the opposite of the sine of the positive angle. 225, negative 225 are opposites, and I got the opposite answer. This is an even function. I'm sorry, odd. The opposite of the angle gives me the opposite value of the side length. The opposite of the angle, 30, negative 30, gives me the opposite value. Opposite angle, opposite value. Opposite angle, opposite value. This says equals. Okay, why is that true? Why is that true? So if you have an angle in the first quadrant, so let's say theta is between 0 and 90. So if theta is greater than or equal to 0, actually not equal to, if it's between 0 and 90, that's the first quadrant. Okay, if theta is between 0 and negative 90, pi over 2. I should really be using radians. So if theta is between 0 and negative 90, that's quadrant 4. So the opposite of if an angle between 0 and 90 would be an angle between 0 and negative 90. So what's that look like? Doesn't matter what the value of the angle is. If you are between 0 and 90, any angle between 0 and 90 degrees is in the first quadrant. And if you take the negative, if you take the opposite of that angle, so any angle that's in the first quadrant, 27 degrees, 59 degrees, 67.32 degrees, theta, first quadrant, then the opposite of theta is in the fourth quadrant. Always true. If theta is in the second quadrant, then negative theta is in the third quadrant. If theta is in the second quadrant, somewhere between 90 and 180, somewhere between 90 and 180, negative theta is somewhere between negative 90 and negative 180. So this is 90, 180. This is negative 90, negative 180. So if you're an angle in the second quadrant, the negative angle would be in the third quadrant. All right, well, if you look in the first quadrant, this is your opposite side. This is your adjacent side. And what happens is, in the first quadrant, the opposite side is positive. In the first quadrant, the opposite side is positive. Sine is opposite. While in the fourth quadrant, the opposite side is negative. Fourth quadrant, opposite side is negative. First quadrant, opposite side is positive. And so that is why when you have theta and the sign is positive, negative theta, the opposite side is negative. So hence why it is the sine of negative theta is equal to the opposite of the sine of negative theta. Okay, well, what about cosine? And who cares? Like, why does this even matter? Can't you just draw it and figure it out? Like, do you really need to know this whole like opposite, even, odd thing? You do, because we're going to do proof. Yeah, we are going to do proof. And when we do proof, you're going to have to know. So along those same sides, same lines, the cosine of theta is equal to the same as the cosine of negative theta. And it goes along those same lines. And by the way, this would be even. So going back here, they share an adjacent side. So theta is in the first quadrant. The opposite of theta is in the fourth quadrant, but they share the adjacent side. That doesn't change. Theta, first quadrant. Opposite of theta, fourth quadrant. They share an adjacent side in the triangle. So you get the same value. So that's like saying the cosine of 45 degrees is the same as the cosine of negative 45 degrees. And that is indeed true, sorry. Those are both root 2 over 2. There's 45 degrees, and the cosine of 45 is root 2 over 2. This isn't actually the greatest example because it's a 45, but well, so this is negative 45 degrees. Cosine is adjacent. My adjacent side is still root 2 over 2. So this is considered even. So if you're asked to find the cosine of negative 7 pi over 4, that's the same as the cosine of positive 7 pi over 4. So you don't need to worry, well, maybe you don't need to draw either one of them, but the sine of negative 7 pi over 4 is the opposite of the sine of 7 pi over 4. Cosine, the negative angle, the positive angle are the same. Sine, the negative angle is the opposite of the positive angle. Okay, so what about tangent and cotangent? And again, why does this matter? In terms of drawing a triangle, if you can do it off the top of your head, that's great. But instead of drawing negative 7 pi over 4, you should use the fact that the properties, the odd even properties of the function. And this is going to matter. I'm telling you that this is going to matter when we start doing proof. And we are going to start doing proof. So the tangent of negative theta. Well, isn't that the same thing as the sine of negative theta over the cosine of negative theta? And the sine of negative theta is opposite of the sine of positive theta. And the cosine of negative theta is the same as the cosine of positive theta. And this is negative tangent theta. So the tangent of negative theta is the opposite of the tangent of positive theta. Cotangent. The cotangent of negative theta is the cosine of negative theta over the sine of negative theta. And this is going to be exactly the same as above. Cosine of negative theta is the same as the cosine of positive theta. And the sine of negative theta is opposite. And that's negative cotangent theta. Both tangent and cotangent are odd. Plug in the opposite of the angle, you get the opposite of the function. Opposite of the angle, opposite of the function. Last thing are three very, very, very important identities. Very important identities. Last thing. Oh, geez, that's terrible. Gosh. Your other teachers probably draw these beautiful pictures, and mine are just atrocious. Okay. You have some right triangle. And you have a right triangle, the Pythagorean theorem always works. If there's a right triangle, Pythagorean theorem always works. So you have A, B, C, and you know that A squared plus B squared equals C squared. Okay, well, does it matter if it's A and B? Can't we say X and Y? And if we're talking about the unit circle, which of course we are, hypotenuse is the same as the radius. I hammered that in a different video. X squared plus Y squared is 1. And if we're talking about the unit circle, aren't we talking about the cosine of some angle and the sine of some angle? So instead of saying x squared, can't we say cosine squared? The squared is between the s and the theta, plus y, which is sine. These are all true. This is the Pythagorean identity, and it is now added to your list of most important math things that you should know. Pythagorean theorem, quadratic formula, y equals mx plus b, like this is now on the list. So, using this primary, I call it the primary identity, but it is the Pythagorean identity. I don't know, we never write cosine first. We always write sine first. Poor cosine, gets the shaft. Sine squared plus cosine squared equals 1. There are two other identities that can be derived from cosine squared plus sine squared. If I take this identity and, I'm not going to use that color or it won't show up. If I divide everything by sine squared, sine squared divided by sine squared is 1. Cosine over sine is cotangent. And 1 over sine is cosecant. And you can derive the other primary identity by dividing everything by cosine squared. So sine plus cosine equals 1. Divide everything by cosine. So sine over cosine is tangent. Plus 1 equals secant. And those are your primary identities. You don't have to memorize any of them. Pythagorean theorem, which you can derive by drawing the triangle if you need to, and then do the division by sine squared, voila. Do the division by cosine squared, voila. This video actually is enough to get you through the homework for today, as well as the homework that'll be assigned after Thanksgiving. So you might want to bookmark this one for yourself.